Hi, thanks everyone for coming. There'll be a number of URLs flying by in these slides, so just to tell you, the slides are up there, and I will put that URL at the end of the talk as well, so you don't need to worry about missing stuff. So I'm going to be talking today about a lot of new exciting stuff that's been happening in the Upstream Python packaging ecosystem. It's going to be like a whirlwind tour of a number of things, kind of let you know what's going on. But first of all, what do I mean by upstream packaging? So you think of a Python package lifecycle, something like you write some code, you modify it for a while, and once you think it's pretty good, you use setup.py to make a source release. You might build that into some wheels. You upload your source dist and those wheels, hopefully, to PiePie. And then there's a number of different places they go from there, right? So there's lots of different people who do binary distributions, like Conda or Debian or whoever. We'll download your sdist and then use your setup.py file to build it, and then send it on to end users. Some end users will get the source dist directly from PiePie and build it themselves. Some might install your wheels. So there's a lot of different things, moving parts here. I'm going to be focusing on sort of these pieces. Sort of everything that is the province of upstream Python. So people sometimes ask me, the last year or two I've been working on this, like, why, but Conda just solves everything, right? Why are you working on this? Well, so obviously there's a lot of this is not that is upstream of Conda, that Conda depends on as well. And then also for the parts that are sort of arguably competitors to Conda, I think, well, Conda is awesome. I recommend it all the time. There are some advantages to working on this. So first is that if you're developing a piece of software in Python, you kind of, you want to support your users. A lot of users are on Conda, and a lot of them are using PiePie. Here's 1 month of downloads, right? So there's that. If you're a user, Conda and now Conda Forge, which is really awesome, have a lot of the core important packages available, but sooner or later you're going to need something sort of in this long tail that isn't there. PiePie has 2 orders of magnitude more packages right now. So sooner or later you're going to have to use pip. Right now there's this really bimodal experience, right? As long as you're in Conda, everything's wonderful, and then as soon as you fall outside of Conda, you're just like plunged into the burning flames, right? My therapist says that like the secret to happiness isn't so much making the highs higher as getting rid of those really terrible things and trying to sort of move the baseline up. So if we can make pip better, it helps with that. And also, I think this is sort of a more fuzzy kind of thing, but I want us to stay in touch with the upstream Python folks in general, right? I think the reason that Python is the best numerical language out there is because it's not a numerical language, right? That you have this whole wider ecosystem available to you that we're integrated with. They know things we don't, we know things they don't, and we want to keep in touch. So I'm going to cover a bunch of things today. Let's get started. First, I think this is maybe the most exciting thing, Linux wheels. So you might have noticed that for like say NumPy now on PiePie, there are Linux builds there. You type pip install on Linux, it just happens. Yay, I know. So how did this happen? Well, so swimming upstream is hard. You have to get out of your comfort zone, talk to people you don't necessarily know. We did that. We went up to distutil sig. And basically what we have is there's a PEP, which there's 2 things that we did really. There's a documented specification for how do you make a Linux build that actually will work for everyone. This is not trivial. Until we did this, there was nothing written down on how to do this, which was kind of a problem for building Conda packages too. So, and this was sort of a collaborative effort in a way. We kind of, it's basically a friendly, specified reverse engineering of what folks like Anaconda and Canopy are already doing. But in addition to that, it's not just like a set of rules you have to follow. It's also tools to help you do that. So in one slide, just very briefly, you can find out more. This is how you build a wheel for Linux. So there's this Docker image we provide. So you type this sort of magic command, and let's say you're in your directory, you've got your source tree. You type this magic command. It drops you into this special build environment that we've put together as root in your own little private machine that we just made. And we've imported your current directory is made available at /io. So you have your source there. We've provided a whole bunch of Python versions for you. So you can just say, okay, for each one, call pip, ask it to make a wheel out of my thing, write it somewhere. And then there's this audit wheel command, which will, A, check that your wheel actually is going to be compatible with people's machines. And if you depend on some shared libraries, it will rewrite your binary in your wheel and copy the shared libraries in and make sure that it works and it doesn't collide with any other copies of that shared library the user might have. Just nothing to it. Now you know how to do it. Go forth, build wheels. If you run into any trouble, we also have a mailing list now, official mailing list at python.org, Wheel Builders, which is your packaging help desk. If you have any trouble, come ask. We're friendly. So yeah, do that. Shared libraries, like I just mentioned, are one of the big problems for scientific packages if you're trying to distribute things, right? So it's like I could build my code, but then I've got BLAS and some weird image processing library, and it's terrible. So there's a few different ways you can try and deal with that. Actually, let me give you a brief digression, right? So, for example, on these Linux wheels that I just told you about, and NumPy is using, we're just shipping OpenBLAS as part of that. That's what we're doing. It works great. It's fast. There was some work we had to do that, because it turns out OpenBLAS historically is really buggy. Like really, it's bad. We first put up our test wheels. We had like 5 different people saying we're getting weird seg faults, like in the first hour. And like this, so I talked to the Julia build manager, and he said, oh yeah, we ship OpenBLAS. It's kind of, I mean, we kind of get away with it because there aren't that many people that use our stuff yet. But I mean, you have too many users. I don't think you can ship OpenBLAS. Which was true. So we went up to the OpenBLAS developers and we talked to them. We said, we have this problem. Look at these bug reports. And there's this thing called continuous integration. Let me sit down and like explain to you what that is and why you might want it and all of that. And amazingly, this worked. So as of like 6 months ago, I forget, OpenBLAS now Upstream has set up continuous integration. They have machines running every different weird little variant of the Intel architecture, because that's all like different code paths you need to check. They're running nightly tests of as they develop. And they're running their test suite, they're running NumPy's test suite, they're running SciPy's test suite, and they're running the scikit-learn test suite on all of their code. And they fixed all the bugs. Yes, applause to them. This is awesome. And now we can ship it. And now you can use it. It's great. Okay, back to shared libraries and wheels in general. How do you deal with them? So the first option, like I said, is you can just bundle them into your wheels, kind of like what people do on Windows and Mac. On Linux, or in general, on Linux, this is just like a solved problem, right? Audit wheel, you have to figure out how to build the shared library and get it to work at all, but once you've done that, it knows how to take care of the actual bundling. It would be really great to make that work on Windows and Mac as well, to have that same kind of convenient tooling. We know how to do it. Someone needs to do the work. Maybe that's you. The more complicated, sort of the next step is you would like sometimes, for some things bundling is fine if you're sort of the one person using something. But sometimes you have libraries that are, BLAS is like, 10 megabytes or bigger. You don't really want NumPy and SciPy and scikit all shipping their own copies. Or there's things like OpenSSL, where you don't really want like 10 different copies hiding in your system, and then there's a security problem, and it's kind of a mess. So things like that, it would be really nice to have like an OpenSSL wheel, say, that ships on its own. You just have to update that, and everything else can use it. Or BLAS, same thing. We have, again, I have a detailed sketch for how to make this actually work. It's not quite ready yet. Could use some help, but that's sort of just status update. That's where things are. We know how to move forward at least. Moving on. Another big thing, the Windows problem. It gets capital letters, right? So the Windows problem is, it's trying to build software for Windows, and it's terrible, right? But specifically, our problem is that as people building scientific software we want to distribute, and some of our users use Windows, even though almost none of us do because it's so painful because of these issues. We need a tool chain that targets Windows and that we can use so it doesn't have like weird licensing restrictions on the built code, like say the Intel C compiler does. It needs to work with CPython, which means it has to work with sort of this wide range of different versions of MSVC, which is this whole pile of mess, something. And the reason we can't just use MSVC is we need things like Fortran and inline assembler and modern C++. So how can we solve this problem? It turns out GCC is like almost there. The one issue is here Microsoft has these libraries for, for how libc works basically on their platform. But because of like weird technical decisions made long ago and some really obnoxious licensing things about what Microsoft does, we can't, GCC doesn't work well with those right now. You would think that Microsoft would be like, well, we want people to use our platform. We're like selling, like, yeah, you come do data science on Windows. They might want to fix this, but well, all the individual people I've talked to at Microsoft seem to really get the problem, maybe want to help and everything. Microsoft as a institution has been totally unable to do anything useful here. So the current status is, yeah, we have not managed to get any resources from them. It is still the case that, like, if you want to build software that uses their libraries, you need like the header files and such. Like, it just describes how to do that. The only thing you can do with those header files is build software for Windows, which you think they'd want you to do. But their license says that GCC can't use those header files. So we waste an immense amount of effort trying to reproduce them from scratch. It's totally pointless, but they have not yet figured out how to change the license either. Anyway, sorry, I just had to say, like, you have to give some feedback to companies sometimes. So Microsoft, you could do better. Nonetheless, we press forward because what else can you do? The current situation is really, really painful for all of us trying to support our users, right? And so we've talked to the GCC folks upstream to try and figure out what's a good plan. And roughly, here's what the plan looks like. Is for older versions of Python that uses older versions of MSVC. For technical reasons, those are sort of more difficult for them to support upstream. They don't want to do it. And it's also, but the actual changes needed are smaller. So there's the Mingy, that's misspelled, Mingy WPy is what it's supposed to be. There, that's right. Which is technically a fork, but the patch set is not large, of Mingy WW64 designed to work with those old versions of Python. We have a small amount of funding from NumFocus and the PSF mostly. And it is there, it works. It needs some polish. It's not really something I can recommend you go out and start using for real today, but you might want to help, for example. And then we have plans for the new version of Python used the new version of MSVC, which totally changed how they did their internal libraries. So this is bad news in that it makes it harder. There's more work to be done to support it. But it's good news in that the new system is much more sensible. And it's something that the Mingy W64 and GCC developers are actually willing to make their official, like, you just download GCC and it just works thing. So we're currently in the planning stages to figure out how to get resources and such to make that actually happen. So that's the status. Sorry I don't have more good news, but at least there's something happening on. Oh, right, further, the theme about why it's good to talk to people upstream. I want to give a brief digression about one thing we encountered as these Windows build stuff. So .lib files are this weird Windows thing. If you want to link to a DLL on Windows, a shared library, you don't link to it directly. So you link to this .lib file, which then tells the compiler to go link to the DLL. Whatever. There's lots of things that you'll find online saying, oh yeah, the .lib files that MSVC produces, those don't work with GCC. Instead, so you can't just like download someone's library and use it. You have to like first do some cumbersome process to recreate it, and it's kind of a big mess. So I thought, well, is there any, why is that? Can't we just use that? So I asked the GCC maintainer, and he's like, oh no, you should be able to just use that. So I tried it, and it didn't work. So I thought, well, but what's going wrong? So I went and started digging around in this .lib file to see what is actually going on in there. Now, you might think like, what the heck, Nathaniel, you are not a compiler developer. And that is true. I am not a compiler developer in any way. I have no idea how these things actually work. But I am a scientist. I'm used to dealing with, probably a lot of you have seen file formats look like this, right? So this is, I think, the nifty file format for fMRI images. It's like, well, if you want the data array dimensions, you go 40 bytes in, and there's an array of 8 shorts. And this is familiar, I think, to a lot of people here, probably. So you can go to Microsoft's website and say, what's a .lib file look like? And well, it's got a bunch of fields in it. So, it's like, okay, I know how to do with that. And it turns out, I was digging through it, there's this field down here where there's a little flag that says, what is what basically just has a list of all the different functions and variables that are exported from the library, right? So that the compiler knows to look at them. And each one has a flag saying, is this a function, or is it a variable, or is it something else? And it turned out GCC was looking for the functions, but skipping over the ones that had the variable flag set. So that doesn't work, but it was like a 5-line patch, right? It was just like a if X or Y, then, right? And yet for like 10 years, people are saying, oh no, you can't use these, right? Like, I think we should expect better. we should try things. We have some of these skills. We can make things better. So I submitted this 5-line patch. It's merged now, and now you can just use .lib files. Yay. It's not that big a deal, but let's move forward. Okay, further updates, stuff that we don't have anything to do with, but you figure you might want to know about. You might have noticed if you work with PiePie that it's like kind of falling to pieces. You've been broken, like stats have been not working and so on. If you've ever looked at the source code, it's completely unmaintainable. And there's also sort of a background problem, which there's basically one guy who is the one person who does PiePie and pip and twine and virtualenv. This is a familiar story, I guess, to all of us. But so they're very resource limited. But what's going on to fix the PiePie code base is impossible to work with thing is they are actually rewriting it. And it's at a new domain name. Right now it's still in beta, but it's using the same database. So if you go here, you can download things. And it actually works better already for almost everything. So you should check it out, start using it. It's pretty good. One of the other things that is, I think, going to be really interesting to some people here is that as part of the new stuff, they've redone how the stats work. So there's now a giant Google BigQuery table that's public, which has a list of every download made from PiePie. So you can just write a little bit of SQL, and it'll go away for a few seconds. And so this is just saying how many times was NumPy downloaded in this month, and it pops out. But you can say things like, how many people downloaded my package during lunchtime of this SciPy sprint, and of those, how many of them were using Ubuntu 16.04 versus 14.04? Or you can just do that. It's pretty cool. Check it out. And another thing that's going on, oh right, and this is actually an old thing, but I just wanted to highlight it since I'm here, advertise it. There's this cool feature pip has. You don't get it with Conda. Maybe you should be able to get it with Conda, but you can't right now, which is that you can upload a pre-release to PiePie, and pip by default will ignore it unless you say -- pre when you're installing with pip. So if you're a developer, you should upload your pre-releases to PiePie, because you want people to test them, right? That's the whole idea. This makes it really easy. And if you're a user, if you're maintaining a continuous integration system or something, use -- pre, like always, because if you don't, then the bugs are just going to go in the release version, and then you're going to have to deal with them. It's going to be more painful. So just go. Everyone should go and change their travis.yamls right now and add that. Okay. Oh wait. No, I won't. I don't have time. Okay. Another update. Another exciting thing I think that's going on that this is just starting up in the last month or so, is that like I said, there's this problem where there's one guy who's the only reason that Python packaging exists. Or continues to exist. I mean, there's other people that help, but really, he's carrying it on his back. And we're sort of starting to try and figure out how can we address this in a more systematic way. So the PSF now has formed a packaging working group, has the ability to take donations. This is a new exciting thing. And is starting to think about sort of the bigger picture of make plans for how to raise more funding, make this more sustainable. And this is, again, speaking of ways in which different groups can help each other. It turns out that I am by no means a magical getter of grants, but I know a lot more about it than they do. So I'm helping them out. I mean, you could help too, right? So, we're all in this together. And the last thing, sort of saving the second best thing after the Linux wheels for last, is this. Okay, so let's motivate it first. So here's 3 different annoyances that come up when you're working with Python packaging, I find. So one is, you start a new project. Before you've even written any code, you've got 5 different tools that you're trying to set. I mean, come on. It's kind of annoying. It's not a big deal, but it's kind of annoying. A much more annoying problem is suppose you want to use NumPy's C API, then you need to import NumPy and call numpy.getInclude so that you can actually build your code. You need to pass that to setup.py. But what if NumPy is not installed? Well, setup.py has a solution for that. You just pass this argument saying, please install NumPy. Of course, by the time you pass that argument, you already had to import NumPy, so this is totally useless, right? It's just, yeah, there's really not a good solution to that right now. That means the answer is just builds fail and people have to install NumPy and everyone suffers, right? And then finally, this is a more general point, but like, well, distutils, setuptools work, they get the job done, I've distributed code using them, it's fine. I just never want to use them again, right? Who here wants to? Yeah, okay. Oh, no, sorry, I messed up this clapping. Okay. Who here wants to not use them again? Yay, I know, me too, right? So here's the plan. There's a new file, because we had too many files, I'm adding one. This file is called pieproject.toml. It's defined in PEP 518. So there's two things it does right now. So one is you can put tool dot the name of any name you own on PiePie, and then you can put your configuration in there. And so the idea is that all these different tools are going to converge on that. So there's this one file you have to configure that has everything in it. The next key thing is there's this build system key. So you can say that pip will look in here before it calls setup.py and install whatever it tells you there. So you put numpy here, now it works. That's not implemented yet, but it is standardized and it will be soon. And then the next thing, which is still in progress, but we're still fleshing out the details, is we'll add another key which says, in fact, instead of calling setup.py, import and run this code. That will make a wheel for you. And that means now everyone can write their own build system, which might cause its own set of problems. But hopefully some good ones will emerge and they won't be distutils and we'll be much happier. But one important consequence, just to advertise users, this means in the future, setup.py won't always be there. Instead of running it directly, like to build, you should use pip wheel, or if you want to install, use pip install, and that will keep working in general. And also just works better already right now. Okay, so that's the end of my whirlwind tour. Where do we go from here? The message I want to leave you with, right, is that Python packaging is getting much better. There's lots starting to go on. It's really great. But we do need your help. Like, there were some exciting things there. There was a lot of like, okay, we know what we want. We just got to do it. So go out there, fix your scripts to use -- pre. Subscribe to Wheel Builders. We'll help you build your wheels. Let's start working on Audit Wheel to make it work on Windows and Mac. Make that easy, just as easy to build wheels for them as it is to build for Linux now. Let's make the OpenSSL, Open BLAS as a wheel. Make that a reality. I need your help. Let's improve our tooling stories. Let's improve the docs. I think there's a lot of room. I didn't have time to talk about any ideas here, but I think there's a lot of room for Conda and pip to sort of work better together. Let's do that. Come help us with the PSF packaging working group to make things more sustainable, and tell your boss. You need help. You should also check out, if you were interested in this talk, you should definitely check out Phil's talk tomorrow. Same place, half an hour earlier on Conda Forge, which is super exciting. And let's get to work. And I finally just want to thank some of the many people who've helped make all these things I just said reality. This is by no means a one-person show. There's a lot of people involved. And there's that slides URL again. Questions? Yeah.
Does the package model have entry points like the setup used to? So where you could register other packages as part of shared namespace or some functionality?
So the question is, in setuptools, there's a feature where you can have a setuptools plugins that you install, and that sort of magically, if they're installed, they reach into setuptools while it's running and change how things work. And the question is, does pieproject.toml have that same thing? And the answer is, so right now, pieproject.toml is, it's just a file that things can look in. So it's a place to store configuration for different tools, right? So at that level, if those tools want to have plugins or something and they want to configure them there, I guess that'd be fine, but it's up to them. And as far as sort of the new build system stuff to like try and replace setup tools, that the idea here is that, I mean, a lot of the problem with distributed setup tools is that try to sort of be the one-stop shop for everything. And it works great if you were doing something that they thought of, and then it falls apart as soon as you're doing something they didn't think of. So now we're trying to take sort of a different strategy, say, let's try and get the upstream Python packaging out of the business of trying to make a list of every single thing people need. Specify just the minimum thing we need, and to let different build systems plug in. So there could be like, Thomas Claver has this really awesome tool called Flit, which is like, replaces, is a distutools replacement thing. And its strategy is it has a very narrow focus. It doesn't try and build extensions or anything. It's just for pure Python packages. But then for those, it handles really well. But you might imagine some other really complicated, sort of numpy.distutools kind of replacement that tries to solve how do you build Fortran and all that. That kind of thing might want to have some plugin API. I don't know, but it's up to those individual packages. It's not going to be specified here. Okay. Sure, back there. So the question is, or the statement, I guess, is that distutools has a function to install headers, and maybe NumPy should use that instead of the get include thing. And I think don't like quote me on this. I guess I'm being recorded, so I can't help that. But okay, pretend I'm. I think that install headers thing is a lie and a trap, and like just doesn't work very well. Like there isn't a standard place to put them, there isn't a standard place to look for them. And NumPy's thing actually works much better is I think what's going on with that. I mean, and really NumPy's thing works fine as long as we fix this, which we have to fix anyway. I mean, in particular, you have to say, if you want to use Flit as your build system, you have to have a way to say, I need Flit installed before you start the build system. So fixing the build requirements thing is just a great idea anyway, and it solves that problem. So one more question. Anyone? You're closest, sure.
So I'm curious, is there eventually a plan to possibly enable cross-compiling for OS X and Windows? Would that ever be possible? Or do we always need OS X and Windows machines?
So the question is there a plan to enable cross-compiling, I guess, from Linux to Windows and OS X?
The Docker image you have, that's really awesome.
Yeah. Right, because Linux has Docker, which makes things easy, and they don't. And are you jumping in because you want to answer this? So.
I've been working on bridging Python system and CMake, and from setup.py you can include SciPy, and since you use CMake under the hood, if you have a tool chain, for example, if you want to cross-compile for Windows or Linux, you can use MSVC, and then you will be able to build for Windows. And you're going to sprint this weekend and to add support from common file, automatically easily with the CMake cross-compile.
Okay. Yeah, I'm not sure I caught all of that. I won't try and summarize it all, but I think it was basically, at least some people are working on like CMake-based tools for cross-compiling. And I think the general answer is that like there is no general solution to cross-compiling because it depends on individual build systems and packages and what they need. But I think there's definitely interest in that. Like, so if we get GCC working as a good Windows compiler, then you'll be able to run it on Linux, for example. OS X is a little tougher. OS X is kind of a problem in a number of ways because of the thing where you can't virtualize it. But yeah, if you have any thoughts, definitely be glad to hear it. And now I'm out of time. All right. I will be around. I'll be at the sprints. You should come and sprint or ask questions. All right.